It's a lecture 8 for CIS6395, the incident response technology. So I will finish the introduction of the Wireshark. Then I will use some concrete example to explain how you can use Wireshark to analyze network trace and collect real-time network traffic to understand the behavior of any program running using this network. Okay, one student asked, I still need to install Windows in VM. Yes, in two classes ago, I introduced the virtual machine. So you should install at least Kali Linux VM and Windows, either Windows 7 or Windows 10. It doesn't matter, either one is fine. And also Metasploitable Linux VM into your VirtualBox. Like this is what I did. I installed this Metasploitable Linux and Kali Linux and the Windows 10 VM. You can install Windows 10 VM or Windows 7 VM or Windows 8. There's no difference. Okay. Later on, like when we introduce penetration testing, we will need to install another Windows, which is a vulnerable Windows XP, a virtual machine. But this Windows 7, Windows 10 you are installing on your VirtualBox is just for normal testing purpose. It's not use them as the victim. You don't need to compromise these kind of Windows VM right now. So just install any one of those download Windows virtual machine. Okay, so let me open the slides. Okay, so last time I explained that in Wireshark usage, the main operation is on display filter. So these are just some syntax of display filter. Can you repeat that? Or just you need to install Kali Linux VM, Metasploitable Linux VM, and either Windows 7 or Windows 10 VM on your VirtualBox. For in the following lectures, we will need to use those virtual machines to do some experiment, to install some free software on the virtual machine to do some software operation. Usually you should not install like many free open source software on your host OS because maybe they are not very secure. So for the class, for all the other main, for many open source software, I will ask you to install on the Windows VM or Kali Linux VM to use them. Okay, so these are just some display filter examples. The display filter, the syntax is like is first the protocol, then out the first substring. Basically, any field related to that protocol. For some protocols, they may have a second substring to further specify a specific field for that protocol, for that packet header. Then after that is operation, comparison operator, like a bigger, smaller, equal, and then there's a logical operation like and or and bracket. You use that. So So TCP, this is TCP header information. So we use TCP a lot. So you need to memorize. You don't need to memorize their size, but you need to know what kind of information is included in TCP packet header. So here is example, like you can say TCP.flags. So this first substring just represent what's the value for that flag field. Flag field is there are six bits used for the flag field. So if you say flags equal to 2, then that means only the same bit set as 1. All the other bits they are set as 0. So that is a same packet. Or you can use this way to represent these packets, tcp.flags.syn. So for some protocol, they may have 2 substrings, but for many protocols, there's only 1 substring. How do you find this substring? You can in the Wireshark, in the display filter, you can say TCP dot. Then basically it's a drop-down menu. It will show all the substring related to the TCP protocol. So this is one easy way to do that, and flags. And you can see that what's the second substring possible for this flags field. Another way to generate this display filter is that you can use you can click this flag in front of the display filter, and you can see these are some pre-existing display filter pre-built into this. So for example, you can click this, then it will use this pre-exist display filter. I think that's the way to do it. Filter button manage display. So here are some pre-existing display filters. So you can add additional more display filters. For example, some display filter that you frequently use, then you don't need to type it every time you want to use it. You can add them. You can use this add to add a new display filter, preset display filter to your own Wireshark. So later on, you just use this preset one. And remember this comparison operator is this logical operator is AND, OR, XOR, or NOT. So you can either use English format, or you can use this C program language like format for this comparison operator and the logical operator. Like this display filter basically display any packet that is either SNMP protocol or DNS protocol or ICMP protocol. TCP.flags, if you don't give any comparison operator, then just display any packet that have a TCP flag field. Well, basically any TCP packet, because every TCP packet header has a flag field. So you can just simply type TCP and that's all. TCP.port. So this doesn't specify whether it's a source port or destination port. So this just means either the source port or the destination port is equal to 25. So display TCP any packet that from and to this port 25. So if you want to display only one direction, then you just use a TCP source port or TCP destination port, like TCP SRC port is a source port. Or you have to check that screen. Big screen, they still haven't repaired. The big screen looks fancy because you can write on the screen, but it's too complicated and then it may not support. So if you say TCP source port equal to 80, equal to 80, then just means you won't find any traffic coming from the web server to client, because source port is 80. These packets can only be sent by web server. So you can see that basically all the source IP address should be the web server's IP address. Because all the traffic here is web server to client, to browser. But if you type here as the ST port, ST port means that destination port. If you use TCP.destination port is equal to 80, then this means the destination port should be equal to port 80. Then all this traffic should be the traffic sent by browser to web server. Destination is web server. So all the destination IP address here should be the web server IP address. And the source IP address here should be the browsers, basically client computers IP address. Because this trace is what I demonstrate in last class. So in last class, when I collect the traffic, I use browser to connect my homepage. So this is my computer's IP address. This is the CS department web server. So you can see this is HTTP GET command to get the page. Remember, last time I connected to my homepage. This connection is not secure. Basically, is using port 80 for the connection. That's why in Wireshark we can see the actual content. And the port is port 80. Okay, so make sure you understand the destination port, source port, how you can use them. You can use them to specify which direction of traffic you want to display. Okay, after you have filtered traffic, you can save all filtered packets into either text file or save them into the PCAP format. PCAP file is basically the Wireshark saved trace file. So then you can analyze them later. For example, the in-class example originally is 5 megabytes, so it's very big. Suppose I'm only interested in web traffic. Suppose I'm only interested in HTTP traffic, because HTTPS is encrypted. There's not much information you can get. So because last time I connected to my homepage, this is HTTP traffic, then this trace is too big. It's 7,000 packets. So suppose I only want to keep any traffic between my browser to the CS web server to get my homepage. That is port 80 traffic. Then I can type TCP port equal to 80. This doesn't specify source port or destination port. So basically, both direction of traffic between my browser and the CS web server. So here, all the packet is related to that connection. And now the displayed packet, you can see the status bar, only 171 packet. So that is much smaller and much easier for me to analyze, even manually analyze. I can still manually go through this 100 plus packet. Suppose I want to save this result into another trace file for later analysis, because sometimes network trace is too big. You use display filter only to display the packet that you're interested. Then you can save them into a smaller traffic trace file. Then you can do further analysis later. To do that, you use file, save as. No, it's not file save as. It's, I think it's export specific packet. Let me see my slides. Export. Here you can specify, like this is a save type. We still save in this Wireshark pcap format. And you can either save all the packet, or you can save the displayed packets. So here is, we select all the packets. If you select this, then basically save all the 7,000 packets. But if we only want to save the displayed packet, then it's 171 packet. Then I can save its name. It's port 80 traffic. Now you can see that this file only 143 kilobytes. So that is much, much smaller. And if I open this traffic trace, now it only have 171 packet for me to analyze. So that is much easier for me to analyze this part of traffic. So that one, I'm saving them into the Wireshark trace file format, because Wireshark trace file format contain all those packet content in them, so we can analyze them later using Wireshark. Suppose you only want to export some basic information. You can export them into a text file, or export them into a CSV file, so that you can use Excel. For example, later on, you can use either Excel to import this CSV file to display those information, to draw some graph, or you can use some other program language to process this pure text file. Suppose we just still use that TCP port 80 and export packet dissection as, for example, as CSV format. Suppose I still export all these displayed packet. The packet format you want, whether you only want the packet summary line, or do you want the here include packet heading? Do you want the packet detail to be displayed? Suppose I just want to have the summary line. The summary line just means whatever displayed in the first sub-window, this line will be exported and into, for example, CSV file. Then I can use Excel to open that. Then you can see that whatever displayed in Excel is basically the packet number times source IP address, destination IP address. Everything is look exactly the same as the first window. Then you can use all the Excel operation, like you can draw some picture and calculate some statistic. You can all use them, use Excel to do this operation. So that's the two type of export that is useful. One is export only selected packets. Secondly, you export this summary line, so you can use Excel to process them. I have already explained this. You save the filtered packets in Wireshark format after you use the display filter, so you can make this trace file much smaller and much easier to analyze. Okay, next I will introduce some statistical analysis function provided by Wireshark. So Wireshark not only provided this basic operation, but also included many statistical function in it. So you can use Wireshark to easily find out how many packets belong to this protocol, how many packets belong to the other protocol. So they are built into the Wireshark menu. For example, the first is the protocol hierarchy. Then if you click the protocol hierarchy, then it will show a summary page of all the network packets in this network trace. What's their distribution? Like, I can just use my example to show. You can do this operation by yourself. You can you open your Wireshark, collect your own traffic for 1 minute, 2 minutes, then you can do all this operation by yourself. So here is a statistic protocol hierarchy. Then it will show that 100% of packets belong to IP version 4. So basically, there is no IP version 6 traffic. And 100%, did I clear the display filter? Okay. I clear the display filter, then it will show all the packet information. Now it should be fine because you can close or open each tab, so you can see that 100% packet belong to IP version 4, and 93% packet belong to UDP. Only 6.4% belong to TCP. This is because when I did my Wireshark capturing in the class, the main traffic belong to the Zoom meeting. Zoom meeting is keep sending UDP traffic because Zoom is multimedia traffic. They use UDP for their traffic in order to avoid time delay, time jittering stuff. So the majority traffic actually belong to UDP. And if you collect your own computer's traffic, you may not have so many UDP. You may have only a small fraction, less than 10% fraction belong to UDP. The most traffic will belong to TCP. And there are a little bit ICMP packet. ICMP is like a ping message. So here, and you can look for detail, like I can open this TCP, then you can see it's 1.9%, basically 143 packets using transport layer security. This is the TLS, basically for all HTTPS traffic, the secure web traffic. They are using TLS to provide the encryption on the transport layer part. So this is the TLS, and HTTP is only 10 packets. The other is TLS because my web browser, besides connecting to my homepage, all the other connections, they are using HTTPS. If you connect to ucf.edu, it's HTTPS. If you connect to any other UCF website, most likely is HTTPS connection. And here is ARP protocol. So only one packet in the ARP protocol captured. So here is showed the hierarchical structure. And you can copy, suppose you want to print out this page, you can copy them. You can copy everything into CSV format or another format. I don't know what program use that format. Then you can use Excel to import whatever displayed here into Excel. So you can use Excel to do the drawing. And you can see my trace like in the beginning. In the beginning, all the packet is UDP. All the packet is UDP. It's basically from my computer to I believe this IP address is the Zoom server's IP address, but I can check. This is the IP address is 144. Okay, I cannot copy this, but so 144.195. You can use IP locator to find out where that IP address is. 144.195.3317. And you can see this IP locator tell us that the ISP is a Zoom video. Organization belong to Zoom video communication. So that is prove my guess that this must be Zoom server, because this is my client, my computer's IP address, and all this traffic is UDP. Because I'm keep recording my video, the video is sending to the web server. And there could be, of course, majority traffic is from my computer to the Zoom server, but from Zoom server, there should also be some traffic coming back. So this is like a behave like acknowledgement or some control message from the Zoom server to the Zoom client on my computer. So, of course, the majority traffic is going out. Okay, another very powerful analysis is this so-called follow TCP stream, because for TCP is like every TCP, once you have a three-way handshake set up, the TCP connection will last for a while until either client or the server close the TCP connection. So here, this operation just means you select one of the TCP packets, then you right-click, you open this right-click menu, click this follow TCP stream. Then that means you only display any packet related to this TCP stream from the TCP connection setup to the TCP connection closed down. All the packets belonging to this TCP stream. For example, if I want to check only my web browsing, the connecting to my homepage, that is HTTP. So this displays, if I type HTTP, this displays that web page connection. However, this is only HTTP protocol. It doesn't display the TCP, like TCP three-way handshake setup and TCP connection closed down. All these packets, they are not displayed here because they do not belong to HTTP protocol. So I can basically select any one of those packets. I right-click, then you follow TCP stream. Then this window will show all the data back and forth in this TCP connection. So this is my browser sending data to the web server. My browser sent get get this base HTML file. So here is a get command. You can see the get command host, and the connection tell the server to keep the connection live. Then the TCP connection will keep live and do many HTTP command. And the other is just the TCP header field tell you some more information, like the user agent basically tell web server what's the browser I'm using, because for different client browser, the web server may return different content. Like if a user browse using laptop or desktop, the web server will give one content. But if the user using a smartphone connecting to the website, this user agent will tell the server that this is a smartphone's browser. Then the web server will send back the web page, specially designed for that smartphone's browser. So this blue text is what's sent back by the web server to my browser. So this is HTTP 200 OK. So this is HTTP header, and it shows that the content is gzipped because if you compress the data will be much smaller, and it will save the bandwidth. So compressed, so tell the browser that you need to use gzip to unzip the content. So here is the content. The content is unreadable because it has been gzipped, compressed. And then this is the wet text is another HTTP GET command from my browser to the web server to get the image. And here is the response to that image. It tells you that this content type is image, and it's in PNG format. The E tag basically tell you what's the, so E tag is like the AND notation for the receiving. So when you see such kind of tag, then you know that this is end of this transmission. So you can think this is that way. So this is a PNG file, and here is get another. So you can see that this, if you click the bottom, it will show that overall 106 kilobytes transmitted entire conversation. And in this direction, from port 80 to my browser, because this is port 80, that means this traffic is from the web server to my browser is 103 kilobytes. From my browser to the web server, because the destination port is 80, so this is web server. So from my browser to web server, we transmitted about 3 kilobytes data to the web server. And so basically, so that follow TCP stream is basically generate this display filter, TCP dot stream equal then a number, because in Wireshark, it will automatically give an ID for every TCP connection, basically sequentially give all the TCP connection ID. So this TCP connection is a number 5 in this trace. So it's the TCP dot stream equal to 5. You can say like change TCP dot stream equal to 1, then it follow the first TCP stream. The first TCP stream only have 4 packets. This is a TLS, so that is HTTPS traffic, basically. You can see this port is 443. HTTPS, the web server using port 443 for the traffic. So that is the follow TCP stream, and red stuff is that the Wireshark, suppose you run Wireshark on your own computer. The red stuff is whatever your computer sent to the internet. The blue stuff is what you received from internet. And so that basically equal to TCP stream equal to something. You can use a not equal to exclude that specific TCP connection. Okay, another statistic is called expert information. Here, you can click this cross check to clear the display filter. Then it will display all the packet. So let me see this. Expert information is in analysis menu. Basically, the analysis statistic, these two manual give you the majority of the statistical analysis function provided by Wireshark. You can try each of them. This is analysis like follow TCP stream is that. Expert information. The expert information is more like a security oriented. So expert information will tell you in the collected network trace, what kind of abnormal or not normal traffic exists. So expert information will show you, like, if this is red, that means this may be serious abnormal traffic. This yellow means this traffic you need to pay attention. And so it will use color to specify what's the severity for that abnormal traffic. This one, I don't know why it show XGP as the one that you need to pay attention. Probably because this is text traffic. So basically tell you that these traffic are plain text, so they may pose the security risk or something. And this one is so the duplicate ACK. Duplicate ACK just means remember in TCP connection, when you receive some data, you need to send acknowledgement to the sender to tell the sender that what data stream, what kind of bytes you have received so far. Duplicate ACK just means the Wireshark have find out that either the client or the server have sent that same acknowledgement packet twice. Why that is important? Because if I send an acknowledgement to the sender, but later on I receive the same packet from the sender, then I need to resend my previous acknowledgement. Tell the sender that I have already received this. Why sender keeps sending that same packet? Because maybe the acknowledgement I sent to sender has been lost in the network, or take too long time to arrive at the sender. Sender, when they send the data, they need to wait until timeout to accept the acknowledgement. Then they can move on. If they don't receive an acknowledgement after timeout, the sender need to resend the previous packet. So duplicate ACK just represent that there could be some packet loss happen in the network. So just to give you a reminder that maybe something happened in network congestion or some link failure, but anyway, there are some packet loss. The warning is DNS query retransmission. This warning message just showed for this particular packet, this is 7525 is a packet number. So you can go to the packet trace to find that particular packet. Actually, you can click this and it will show it on the window here. So this shows that this is retransmitted the DNS query. Again, maybe because of network failure, so the DNS query, the client retransmit that same query, or maybe because some attacker trying to poison the DNS server or poison the DNS client. Because when you send a query to the DNS server, before server send you response, maybe attacker will send you a fake response. Because DNS, even though it's very convenient, it's not encrypted. So if attacker monitors the traffic, they can send you a fake DNS response with the same ID, because there's no, it's all plain text. There is no authentication authorization. So the client may believe that this is a response from the DNS server. So this shows that this is warning message. Basically, you need to pay attention. Maybe there's a security risk there. This is more serious. This is out of order packet. Usually, TCP traffic should not be out of order. Out of order only happens if there is some packet error, packet loss. So if one packet dropped, another following packet may arrive earlier, or one packet has been congested too long time, the other packet arrived. So out of order basically show you that something happened in this network. So in Wireshark, it treats this as in this malformed group. So you need to pay attention. There could be, so this is orange, there could be red status in this export information. Those are some particular malformed packet that you need to pay attention. The screenshot on the slides, it's the older version of the Wireshark, so the display is slightly different from the Wireshark you are using right now, but the content is the same. So in the older one, they display into this different group. So error is the most serious group. A warning is a less serious group. Then the notes, you need to pay attention. Conversation is basically show between any source IP address, destination IP address, what's the conversation happened between these two computers. It could, for TCP, it's the 4 tuple value. Basically, if the source port or destination port is different, they are treated as different conversation, because in TCP, each conversation is defined by the TCP connection, that is 4 tuple value. So conversation will show that how many packets transmitted in each direction, how many bytes transmitted in each direction. And what's the source port, what's the destination port, it will show. And let me show what I have here. Statistics. It's in the statistic menu, conversation. So you can see Ethernet, there are two, basically this is ARP protocol. IP version 4, there are 23 conversations. IP address, this is for IP layer, network layer. Network layer, there is no port number. So conversation in the IP, in the network layer is only about source IP address, destination IP address. So it's about IP address A, IP address B. So it will show how many bits transmitted from A to B, how many bits transmitted from B to A. So that is this, how many bytes A to B, how many bytes B to A. And if you click TCP, then TCP will have the port and the port number to use to distinguish. For example, these two conversations, the destination port is the same, but the source port is different. For example, this is the first 3 conversations. You can see the IP address, destination IP address, destination port, they are the same, but only difference is source port. So there are 3 connections. It's the 3 separate connections from the same client to the same web server. So that's the conversation. Any questions so far for this analysis? Yes. Oh yes, Wireshark, you can use it in many other ways. It's a very common general use software tools by IT security stuff. You can build intrusion detection system on top of Wireshark. As long as, well, you don't need to build it on top of Wireshark. You need to build it on top of T-Shark, because T-Shark is the underlying engine. So if you want to generate intrusion detection system when you write a program code, you need to call T-Shark those API functions. Yeah. The Wireshark is a graphic user interface is for human to use. And as I said, you can use this copy button to copy whatever displayed here into a CSV file or pure text file. So you can import into Excel to do further analysis. Endpoint is very similar to this conversation part. Export HTTP, this is another important function. As I said, HTTP, because HTTP is the most of the web traffic is the #1 traffic on the internet. So Wireshark has built in many functionalities, analysis modules for web traffic. However, HTTPS traffic is fully encrypted. The Wireshark cannot do that much. But for HTTP traffic, it's a plain text, unencrypted. So Wireshark has built in that in very good way. You can use file and export object. So here, just these 5 protocols, they are unencrypted. The Wireshark, when you capture the trace, Wireshark can analyze those unencrypted traffic, extract all the objects from those traffic, and you can download them. For web, for HTTP, it just means the web page, the base HTML file, and also all the objects like all the pictures, image, and the videos transmitted using the HTTP protocol. Like here, we have 4 objects that you can download, like this mountain, and it's 10 kilobytes. You can save it, and you can save to your computer. Then you can see that, see this file. So this is a mountain file on my homepage. So because everything is transmitted in plain text, so Wireshark, when they capture the trace, it can analyze HTTP protocol because it understands HTTP protocol. Then get all these objects and save it to your local hard drive. You can also use this to save all the JavaScript. For example, if you visit any website, if the website is unencrypted using HTTP, then every JavaScript used download from your browser, you can download them into JavaScript coding file. So you can analyze all those JavaScript by yourself. And this is a base HTML. This is a base HTML. I will not show it. And all the other is just the pictures. So you can download everything. Like JavaScript, like all the pictures, GIF picture, PNG picture, every object transmitted in the web traffic can be saved. HTTP load distribution basically show all in the old HTTP what's the server for those HTTP server, how many packets has been transmitted, what's the size for those packets. So those are the information. HTTP analysis, you can select another is called request. It will show all the request objects by the client. Like, let me, oh, I have closed that. In which menu? HTTP analysis. Here is it's a statistic HTTP. Then you can select request. Then it will show that what kind of HTTP request command is sent by the browser to the web server. So basically, my browser sent this five HTTP requests. So request these 3 pictures, request this base HTML file, and request this ICO file. This is screenshot just to show request to suppose you connecting to multiple web servers. It will show request to each of those web servers. You can open the request to one particular web server, then you can see what object your browser have request from that particular web server. Okay, last word for Wireshark is that if you want to improve Wireshark performance, first, don't use capture filter. Basically, capture every packet. That is the most efficient way to capture. The reason is because if you put in a capture filter, like only capture TCP traffic, then your network interface will analyze every packet to see whether it satisfies that capture filter. If it satisfies the capture filter, it will save it. Otherwise, it will not save it. If you don't use any capture filter, your network interface card will capture all the packets down. That does not need to do any analysis. So that will improve the performance of Wireshark. Improved performance Wireshark basically means that the Wireshark will use less computing resource, so you can have your computer to do other things. Secondly, the Wireshark will not miss packet. If the Wireshark is too busy, if there are too many packets transmitting in very short time, the Wireshark will ignore many packets because it doesn't have the computation resource to process every packet. Increase your read buffer size, of course, to save more data. Don't update the screen dynamically, because once you're doing the capture, your first display window will keep refreshing to show newly captured packet. So you probably need to minimize your Wireshark to make the Wireshark running without display anything. Then it will not refresh your computer screen. Use a tap. Tap is just like traffic mirroring device. So you put in that device on Ethernet line, then the traffic will be mirrored and copied to the second line. Then your computer connect to the second line to do the traffic capturing. In this way, if your computer is too slow, your computer will not block the traffic going through an Ethernet line. Because if your computer is too slow, the need to go through the Wireshark processing, the Wireshark may not have time, then you may drop many packets. If you use a tap, if there are too many traffic transmitted, only your Wireshark will drop some packet, but it will not affect the original network link, because network link is a physical link. You use a tap device. It's like a T device, monitoring the traffic copy, make a second copy down to the Wireshark computer. Resolve DNS host name. So in my capture here, I do not resolve any host name, like all these IP source destination, they showed as IP address. But you can configure your Wireshark to show the domain name for instead of IP address, if those IP address has a domain name. That means your Wireshark, for every IP address it captured, it need to do a DNS query to find whether that IP address has a domain name associated with it or not. Post-processing, you can process, for example, using Excel. Probably it's the most easy way you use Excel to process them. And you can use some text processing. If you save this into a pure text file, you can use some text processing software. For example, in Unix, it's grep. So grep can do very basic, very quick text processing. Of course, grep is a command line tool, so it's you need to remember some command in order to use grep. So grep a keyword in a file name, then it will display only the lines that have the specific word. This is the find a line without a specific word. So these are some common grep we use. Actually, later on, when I use Linux for some operation on my computer, I will use the grep from time to time. Just whenever you use Linux, some simple text process, you can use grep very efficiently to do. And here are some tutorial on how to use the grep. And Wireshark, because it's very popular software, so there are many public available pickup files on the internet you can download and try it by yourself. Especially, like I provide some link here. In addition, there could be some challenge. So this is like cybersecurity competition. But this cybersecurity competition is specifically for forensic network trace analysis by using Wireshark. So basically, in this competition, the organizer provide you some network trace and ask you to analyze the trace to find out what kind of attack happened, what is going on in this network trace. You need to answer those questions in, for example, in 24 hours or 48 hours. Then they will determine who win the competition. So this is like some Wireshark competition. And here will contain this trace and also the question this competition asks you to answer. Okay, so that's the basic introduction of Wireshark. Let me move on to the Wireshark example. So the first example is actually operation on your virtual machine. The other example, they are from this UC Berkeley's professor's lecture material. So like Dong Song's class is still on her homepage. You can check. This is undergrad class. So in the undergrad class, most of the faculty, they put their class information, lecture notes online. Even in recent years, for this class, particular class, in recent 2 semesters, 3 semesters, the instructor will post their lecture video on their homepage as well. So it's all public available, and you can check more. Maybe I should show you that. well, they put this as in a specific website, and you can see that this is the most recent CIS101 class, and you can see that they not only have slides but also has recording. So you can watch their class recording by yourself to learn their computer security class. So it's very good material for you to learn. This is for the current semester. I don't know if we can see the older class. This is still the new one. This is the older one, I think. Oh, the older one, they are not. It's not easy for me to find, but the older one should be available. You can find their older semesters, the entire recording on their website by yourself. Anyway, so this is very good learning material for you to do self-learning. The first example I want to show is that suppose you are curious, what kind of behavior does a program do on your computer? Suppose you install a new software or a program, you don't know what kind of traffic it generates. Then you can use Wireshark to do the monitoring and find out the behavior for that program. For example, what traffic does Nmap generate? Nmap is a very popular network scanning software. Basically, you can use Nmap to find what service provided by a remote computer. So the question is, what traffic does Nmap program generate? How can we detect if someone is using Nmap on our own computer? So once you know the traffic generated by Nmap, then it will be very easy for you to find out if someone else is using Nmap to scan your own computer, or your own network, because Nmap has a very fixed, specific behavior. The Nmap basic use is, for example, you scan a particular IP address, then it will tell you what service port is open on that particular target IP address, like whether the computer is providing web traffic, DNS traffic, or email traffic. So to do this test, you should not use Nmap to scan a public web server, public server, because they can easily find out that you are using Nmap scanning them. So you should do this on your virtual machine. So you can run Nmap on Kali Linux and scan another VM. For example, you can scan another VM is like Windows VM or this Metasploitable Linux VM. Any one of the VM is fine. So Kali Linux has both Nmap and Wireshark installed. So before you run Nmap, you open Wireshark to start the traffic capturing, then you run Nmap to scan your Windows VM, for example. Then you stop, after Nmap finished, you stop the traffic capturing, then check the traffic trace. So I will just use this one to do the scan, which is Nmap-F, then the target IP address. The -F means the fast scan. It will scan 100 most common ports predefined by Nmap. So I will open my Kali Linux. So I will open my Windows. For Windows, I think the current Windows VM, they have enabled the firewall by default. So if you enable firewall, one thing will be blocked by the firewall, which is the ICMP message. Basically, ping will be blocked. So if you find it, so first you need to find the IP address for your virtual machine. Otherwise, you don't know what IP address you want to scan. Like for Windows, it's the IP config. You can use IP config. Maybe I should make it a little bit bigger. For Windows, is IP config. You can find its IP address. Right now, I'm using network mode. So it's 2.15 is IP address for my Windows. For my Linux, I want to make the text to be a little bit bigger, but no, it doesn't show up. Okay, in Kali Linux, you can change preference. I can make the font bigger. Okay, now the terminal looks bigger. So the terminal is that you click this one is the terminal. So in Linux, you use if config to find what's your IP address. This inet, whatever displayed here is IP address for the Kali Linux is 2.4. So if I use ping to ping 10.0.2.4, I can ping through. So you can see that the ping can get response. Basically, because my two VM is in the same network router, so they are in the same line. Oh, from Windows, I can ping Linux. But from my Linux, by default, if I ping 10.0.2.15, I will not get any response because the default Windows VM, it has blocked this ICMP protocol packet. So the ping that does not go through, but actually it can see the Windows machine. So if you want to enable this ping action, there are two ways to enable it. First, you can simply like a firewall. You can simply turn off firewall, turn Windows firewall off. Of course, if you do this, you should not use your Windows VM to browse the internet anymore because that may be dangerous. If you turn off firewall, then if I go to the Kali Linux to do the ping, I can ping through because firewall has disabled. Another way I can enable that is that suppose I don't turn off firewall because that's too extreme. But I need to open this allow ICMP protocol packet to go through. I can go to advanced setting in the Windows firewall and found the rules. Like for incoming traffic, I should open this ICMP message. ICMP message actually belong to this file sharing. I cannot make it bigger. Let me see. Okay, it's belong to this file sharing. You can see this is echo request ICMP. This is echo request because ping program send echo request to remote computer. Remote computer will send echo response. to the pin sender. So by default, this one is disabled. You can see this this enabled is no. So basically, we need to enable it. You can right click and enable this rule. So echo request, I will enable it. Because this is for domain, this is for private. I don't know which connection my current Ethernet, the Windows VM belong to. So I basically enable this file sharing, file and printer sharing, this echo request for any domain. Enable. This is this one is IP version 6. I don't need to enable it because right now I'm using IP version 4. So I have enabled these two. And then if I do this pin, you can see that you can still go through. In Linux, the pin will go on forever. So you need to press Control-C to stop the pin program. Okay, so now suppose I want to try, it's 41. I don't have time to finish, but suppose I want to try nmap -f 10.0.2. This is Windows, so I need to do nmap from the Linux machine. nmap.f 10.0.2.15. I want to do this nmap, but I want to use Wireshark to capture this nmap traffic. So I need to first open Wireshark. You can see this Windows, the Kali Linux, the table looks very similar to Windows. It's you can use this search to find the program you want to run. So now, because the default interface is Ethernet 0, so you always select Ethernet 0. Then you start packet capturing. After you start packet capturing, I can run this nmap. You can see this right now, my computer, even though I start packet capturing, there's no packet capture because this Kali Linux is very quiet. There's no other background programming doing internet activity. So it's very quiet. So if I run nmap, you can see this Wireshark is keep generating traffic. Then this nmap finished. Now I can stop the traffic capturing. Now you can analyze this Wireshark. If you see this staple, I probably need to display it a little bit smaller. Okay. You can see that in the status part, we have captured 206 packets. 206 packets is generated by the nmap. And now we can analyze what traffic is generated by the nmap to find out its behavior. Then if you analyze this clearly, then you know that whether your computer is under nmap scan by someone else or because nmap behavior is very specific. Okay, I need to stop here because time is up. So I will finish this example in next class. And this Wednesday I will release the second homework. The second homework is about Wireshark. Basically give you some network trace, and those network trace have some malicious activity. and ask you to use Wireshark to analyze the trace to find out, to answer those questions. Okay, that's all for today's class. Yes. When you download Windows, the Windows will, that page tell you that the default password is passwd, is PASSW0RD explaining that. So that's the password. PASSW0RD explaining that. So that's the default password for Windows VM. For Windows, one student asked, will you provide the link to the Windows XP VM? I will provide that later before we introduce the penetration testing. Because right now we don't need to use Windows XP virtual machine. Okay, that's all for today's class. Okay, see you this Wednesday.
Thank you, Professor. See you Wednesday.
Thank you.
Thank you. Bye.